Ladies and gentlemen, welcome to Charles Darwin University. I'm Professor Karen Gibb, Director of the Research Institute for the Environment and Livelihoods. It gives me great pleasure this evening to warmly welcome you to the third Charles Darwin Oration to be delivered by our 2018 Charles Darwin Scholar, Professor Daniel Dennett from Tufts University in the United States of America. Before we begin, however, I'm pleased to invite Vice-Chancellor and President of Charles Darwin University, Professor Simon Maddox, to provide the official welcome. Thank you.
Well, thank you very much, Karen. Can I begin by acknowledging all of you? Thank you for coming, and particularly acknowledging the Honourable Austin Ash, ACQC, and Dr Valerie Ash, Darwin scholars in their own right, I think, in that they've been associated with this university longer than just about anybody else I know, and fantastic supporters. And it's also a pleasure to welcome our speaker this evening, and Susan Dennett, who's a great supporter of Daniel's, I know, and we had the privilege of lunching together yesterday. And the rest of you, thank you very much for coming to, I think, what is a very special occasion for all of us. And before I go further on that, can I also importantly acknowledge that, of course, we are all gathered here this evening on the traditional lands of the Larrakia people, and I extend my respects to their elders, past, present and future, and I extend that respect to elders from any other First Nations groups that are present here with us this evening. I'm very delighted to welcome you all to the 2018 Charles Darwin Oration, and to welcome our distinguished Charles Darwin Scholar for this year, Professor Daniel Dennett, to Charles Darwin University. We are honoured, Dan, that you have accepted our invitation to become the third of our Charles Darwin Scholars, and we're very much looking forward to your oration and to having you here on campus over the next few weeks, both here in Darwin and at our Alice Springs campus in Central Australia. I know that when word leaked out that we had able to secure Dan's engagement, we got messages from all over Australia and elsewhere saying, "My God, you really got Daniel Dennett to come to Darwin? Wow!" And I half expected that there would be convoys of cars heading up from the south towards this iconic centre to make sure they got an engagement with you. But before I invite Dan to speak this evening, I would like to provide a brief background to the Darwin Scholar Program and to Daniel. Since 2009, Charles Darwin University has endeavoured to better connect with and explore the legacy of our great namesake, Charles Darwin, one of the most important and influential scholars of all time. As a young university, we are truly fortunate to be named after such a remarkable man, to be based here in the great city of Darwin, also named after Charles Darwin, here in the wonderful Northern Territory of Australia. We have undertaken a range of activities around this theme, commencing with the celebration of the 200th anniversary of the birth of Charles Darwin in 2009, including a major international symposium and the commission of a wonderful public artwork, Drawing Conclusions, which combines both Darwin's world voyage and his study of genetic variation, that is located in the courtyard of the Chancellery, Building Orange 12. In 2013, we launched our first massive open online course, or MOOC, appropriately centred on our namesake, titled Charles Darwin, Evolution and Tropical Australia, which has received critical acclaim and won a major award from Blackboard International. In 2014, Charles Darwin University celebrated 25 years of university education here in the Northern Territory. It was a year when we celebrated and reflected on our many achievements, which have been quite outstanding for such a young university, now ranked in the top 2% of all universities in the world. It was also the year we established the Charles Darwin Scholar Program, a biennial program to bring eminent Darwin scholars here to the Northern Territory, to stimulate thinking and expand knowledge within the university, and to also engage more broadly with the Northern Territory community about Darwin the man and his legacy. Our inaugural Charles Darwin Scholar, Professor Janet Brown, a science historian from Harvard University, enlightened us all with insights into Charles Darwin the man and his life's work. In 2016, Charles Darwin scholars, emeritus professors and evolutionary biologists Rosebery and Peter Grant from Princeton University gave us extraordinary insights into their life's work with the Charles Darwin oration entitled Evolution in Action, Charles Darwin and the Galapagos Finches. Anybody who got to meet the Grants couldn't help but fall in love with both of them. They were truly special people, and I have no doubt that we're going to have exactly the same experience, Dan, because having had lunch with you yesterday, I think, again, your personality is one that you just can't help but get drawn in to a very productive, happy and engaged debate. So we are particularly honoured and privileged to have you here as our third Charles Darwin scholar to expand our thinking into a new realm of Darwin's legacy, namely the evolution of the human mind. Professor Dennett is University Professor and Director of the Centre for Cognitive Studies at Tufts University in Massachusetts in the USA. He has an international reputation and has received many awards and accolades for his work and has published extensively. To mention just a few of these, he gave the John Locke Lectures at Oxford in 1983, the Young Lectures at Adelaide here in South Australia in 1985. He has received 2 Guggenheim Fellowships, 2 Fulbright Fellowships, and has 5 honorary doctorates. He was elected to the American Academy of Arts and Sciences in 1987 and was awarded the Erasmus Prize, the Netherlands' highest academic honour, presented by Queen Beatrice in Amsterdam in 2012. Professor Dennett is the author of many papers and books, including Breaking the Spell, Darwin's Dangerous Idea, and most recently, From Bacteria to Bark and Back, The Evolution of Minds. Professor Dennett's trip to Australia has been supported by a CDU Fulbright Specialist Grant, and we thank the Fulbright Commission for that. While in the Northern Territory, in addition to giving the Charles Darwin Oration here and at our campus in Alice Springs, Professor Dennett will be the keynote speaker and participant in a major CDU conference, Evolving Minds, Integrating Philosophy, Science and the Arts, between the 17th and 19th of September. I now have very great pleasure in inviting Professor Dan Dennett to the lectern to deliver the 2018 Charles Darwin Oration, From Bacteria to Bark, Charles Darwin's Vision Extended. Would you please make welcome Dan Dennett.
That's right. Okay. I'm thrilled to be here. I'm particularly honored to follow Peter and Rosemary Grant and Janet Brown as the third Darwin scholar. And I've been enjoying the company and the fauna and flora, everything but the humidity. And I will apologize in advance. I seem to have caught that cough that's going around, and I will bear with me if I have to take some momentary pauses to clear my throat. Okay, so that's my book that was just mentioned. Here we go. From Bacteria to Bach and Back. And I'm going to talk about some of the main themes in that book, in the hopes, among other things, that it will entice you to read the whole book. And I'm sure you can get it at the library, or of course you can buy it, and there's an audio version as well. So there's a bacterium. Wait a minute. There's a bacterium. And there's Bach. And how do we tie them together? With this man, Charles Darwin. I'm a philosopher, and Charles Darwin was not officially a philosopher, but he's not the only great thinker who philosophers take seriously who wasn't a philosopher. Here's 4 others. I wonder how many of them you can name. Does anybody know? We have Newton, Einstein, Freud, and Alan Turing. It occurred to me, as I was preparing this lecture, there's no Einstein City. There's no Freudville. There's no downtown touring. There's no Newton. Well, there is. Right near us in Massachusetts, there's Newton, Massachusetts. It's a suburb of Boston, but it was called Newtown when it was founded, and that was before Newton wrote the Principia. So that doesn't count. But here we are in Darwin. And I think it is entirely appropriate that of all the great scientists that I showed on the previous slide, he's the only one that has a city named for him. And I think that's appropriate because by my lights, he is the number one thinker of all times in one regard. He had, I once said in one of my books that I think he had the single best idea anybody's ever had. That was in my book, Darwin's Dangerous Idea. A great idea, but also dangerous. And a lot of people have noted my hero worship of Charles Darwin and think that maybe my appearance has perhaps something to do with that. But in fact, no, I grew the beard earlier. I was trying to look more like Rasputin, I think, and then I just got old, and my resemblance to Darwin has grown over the years, at least my appearance, my visual resemblance. I wish it could grow in all the other ways. So there we are, two evolutionists. What I want to draw your attention to is that strange idea, which is described by one of his critics as a strange inversion of reasoning. And here it is. I'm going to read it. In the theory with which we have to deal, absolute ignorance is the artificer, so that we may enunciate as the fundamental principle of the whole system that in order to make a perfect and beautiful machine, it is not requisite to know how to make it. The caps are in the original. This proposition will be found, on careful examination, to express in condensed form the essential purport of the theory, and to express in a few words all Mr. Darwin's meaning, who, by a strange inversion of reasoning, seems to think absolute ignorance fully qualified to take the place of absolute wisdom in all the achievements of creative skill. Exactly. That's right. That is Darwin's idea, and it is a strange inversion of reasoning, and it's still hard for many people to take it seriously or to accept it. But I think the days of thinking that this is just a theory are over. The success of Darwin's strange inversion of reasoning are just so great that we have to accept now that it's this is beyond question at this point. But it doesn't mean there aren't still puzzles. In fact, there are some extremely puzzling questions. How can a process with no intelligent designer create intelligent designers, who can then design things that permit us to understand how a process with no intelligent designer can create intelligent designers who can then design things? Now you might want to say, is this just a rhetorical question? Or does it perhaps conceal some embarrassing contradiction in the theory of natural selection? I think not. I will say no. I will argue no. But it is tricky to answer. And what I'm going to try to do in outline in my talk is show how we get from a process that is, as Beverly says, a process with absolute ignorance, no intelligence, no purpose, no foresight, how that process can generate, as among its fruits on the tree of life, things like you, intelligent designers who understand, who can make things and create things. It's quite amazing. How does it work? Well, let's look at the tree of life. This is my favorite diagram of the tree of life. And let's see, I guess if I turn around, I can, does this work? Yes, it does. The way to read this is the birth of life here, and this is the present. So everything that's living right now is along this periphery here. And here's the origin of life. First we get the bacteria. Way over here is Bach. Then we get the archaea, or the archaea and the bacteria, which comes first is an interesting question. And all of this great expanse here, these are the eukaryotes, the multicelled creatures made of complex cells, eukaryotic cells. To a first approximation, every living thing that you can see with the naked eye is a eukaryote. And every plant, every fish, every bird, and us, we're all eukaryotes. And that tremendous flourishing all came about because of something that happened right about there almost 2 billion years ago. Maybe more than 2 billion years ago. And what happened was this. There were bacteria, there were archaea, these cells just bumping around. Single cells, they were not very intelligent, but they'd been evolving, becoming more and more competent for 1 billion years and more. And one day, when two of them happened to bump into each other, instead of one of them, here's A, here's B. What happens when two such simple cells collide? Well, sometimes A is engulfed by B and B eats A and gets a good meal. Sometimes A invades B, destroys B from the inside and gets a good meal. Sometimes they both get destroyed. That's what usually happens. But once in a rare occasion, all that had to happen was that when A and B joined forces this way, they created a new thing, an A-B thing, which was neither one took the other apart. And this became a more fit, more competent organism than either A or B by itself. And when it reproduced, they reproduced together. They joined forces and became the first eukaryotic cell. Now, this amazing idea is now in the textbooks, but it was fought over very vigorously not so many years ago, and the scientist most responsible for convincing the world of science that it was right is the late Lynn Margulis, a very wonderful and imaginative and forceful scientist. So, if you look at these two cells, the one on the left is a prokaryote, simple. The one on the right is a eukaryote. Eukaryotes are bigger, they have more moving parts. And with more moving parts, they can have more competence. They can do more things. So this was, in fact, a great case of technology transfer. Think of it this way. These two independently evolving entities came together, and each one, as it were, got the benefit of all of the technology, all of the research and development that had gone into the creation of the other. And this technology transfer doesn't always work. Sometimes it fails catastrophically, but when it works big time. And this was one of the great moments in the history of life on the planet. Now, why do I dwell so much on this spectacular moment? Because I want to say it happened again, or something very like it happened again, and that's one of the main themes of my book. So let's look at the tree of life again, and we want to look in a little more detail at some portion of it. And I'm going to close in even a little more, and you see now the mammals. And if you look at that little Y, let's see if I can find it say that little Y right there, that's about 6 million years, the two branches of the Y. That's how long it's been since we and the chimpanzee shared a common ancestor. So that gives you some idea of the scope of, or the recency of the arrival of us on the scene. So what I'm suggesting is that we should consider evolution as R&D, as research and development. It's a design process which exploits information in the environment to create, maintain, and improve the design of things. And an important thing about it is that it takes time and energy. There are two main kinds of R&D. In fact, I think there's only two kinds of R&D. One of them is evolution by natural selection, and the other is human intelligent design, which is a very recent phenomenon which has only been on the scene for, let us say, 100,000 years, maybe 200,000 years, or stretching it, we might say 1,000,000 years. I'm not too concerned with the dawn. It's within the last 1,000,000 years and not any earlier than that. Now, these two processes differ in fundamental ways. Evolution is purposeless, foresightless, extremely costly, slow, and intelligent design, in contrast, is purposeful, somewhat foresighted, governed by cost-benefit considerations, and usually relatively fast. There are other differences between intelligent design and evolutionary design, and they're very important, and there's quite a bit in my book that talks about them. But I just want to point out there are two different ways of designing things. One of them is the slow, mindless evolutionary way, the Darwinian way, and the other is the intelligent design way that are done by engineers and artists and composers and novelists and scientists and the like. Well, evolution may be slow and costly, but it's brilliant. As Francis Crick once said jokingly, he called this Orgel's second rule after his colleague Leslie Orgel. Evolution is cleverer than you are. Now, let's stop. I want to go back a slide here. This is Francis Crick talking. He's not a creationist. He was not a creationist. He's one of the most eminent evolutionists of all time. And yet, look what he says. He says, evolution is cleverer than you are. He's not a fan of intelligent design with a capital I, capital D. He's talking, though, about how this mindless, purposeless process produces designs, arrangements of matter of exquisite brilliance, ingenuity, fantastic efficiency. Now, here's one of my favorite slides. On the left, as you know better than most people that I showed this to, that's an Australian termite castle, probably right here in the Northern Territory. Very likely here. I don't know exactly where it was taken. On the right is the famous El Sagrada Familia church, La Sagrada Familia church in Barcelona, created by Antoni Gaudí, the great Catalan architect. Now, I think you'll agree that they are remarkably similar in structure. In fact, their structural similarities go deeper than just what you see here. It's quite breathtaking how similar they are. So what have we got here? We have two artifacts made by living things. They're very much the same shape. Actually, the materials are not so different either. But what I think should be clear to everybody is that the processes that created them are profoundly different. termites are basically clueless. They move little bits of mud around and do their robotic little jobs. They don't know what they're doing or why, and they don't have to know, and they slowly, gradually build these amazing structures. Let's call that bottom-up design and construction. Gaudí, on the other hand, was a archetypal, charismatic genius with blueprints and manifestos, and had a complete vision of the thing before it was built, and ordered his subordinates around, who ordered their subordinates around, who ordered their subordinates around. There's nothing like that in the termite system. The queen or king, they're not bosses. They're more like the crown jewels than like a boss. But in the case of Gaudí and his cathedral, he was an intelligent designer, for sure. So now we have two similar outcomes in the products, two very different processes, one of them with an intelligent designer, one without. And now here's the real puzzle. We have bottom-up design, top-down design. Now, a termite colony might have as many as 70 million individual termites in it. That's quite a lot. A human brain might have 86 billion clueless neurons. Neurons are even stupider than termites. There's a lot more of them, but they're not very clever. But here you can see some termites in some neurons in action. They do reach out and make new connections and abandon connections, prune their dendritic branches and build new ones. So they have some activity. They're little agents, but they're very myopic. They don't know where they are. They don't know you from Adam, any more than those termites know really what they're building. So now here's the puzzle. How do you get a Gaudí mind out of a termite colony brain? Because your brain is, shockingly, rather like a termite colony. Billions of clueless little agents, none of them knowing anything about you. They hustle around. If you can make a human mind out of 86 billion neurons, why don't we see termite colonies that are, writing poetry or building bridges or flying airplanes or doing any of those other intelligent things? What's the difference? And the short answer is you can't do much carpentry with your bare hands, and you can't do much thinking with your bare brain. That's a wonderful saying by my former student, Bo Dalbum. And a termite colony is a bare brain. It doesn't have any thinking tools. But an intelligent designer like Gaudí, intelligent designers have well-equipped brains. Where do they get their tools? When do they get their tools? And the answer to that is very, very recently. As you can see in the Tree of Life, it's only in the last 100,000 years, which is a level in that diagram so small it can hardly be represented. This is an utterly novel development on this planet, that we now have intelligent designers made by brains that are equipped with thinking tools. How did they get their tools? Well, here's the wrong answer from Freeman Dyson. Technology is a gift of God. After the gift of life, it is perhaps the greatest of God's gifts. It is the mother of civilizations, of arts, and of sciences. I think that's the wrong answer. It's right except for that first sentence. Technology is not a gift of God. It is something which evolved just the way the bacteria evolved, just the way viruses evolved, just the way every living thing on the planet evolved. So the long answer is this. It's cultural evolution that has designed thinking tools that impose novel structures on our brains, give us new ways of thinking. These are what you might call evolved virtual machines. Or as I like to put it, they are apps that we download to our necktops. Let's think about that for a moment. If you have a smartphone with no apps, or a laptop with no software, not very powerful. It's the software, it's the apps that give it all its power, all its versatility. And what I'm suggesting is not just metaphorical, I'm saying very literally, the secret of our success is that our brains are capable of downloading information in the form of useful ways of doing things that we don't have to invent for ourselves, any more than you invent the apps you put, unless you're an app designer. Very few of us are. You get the benefit of the app without having to design it yourself. You just download it and run it, and it gives you all sorts of new powers that you didn't have before. And I'm saying that something remarkably similar to that process happened in recent human evolution. And it is the source of our power and versatility. Now, in order to explain that, I have already given you Darwin's strange inversion of reasoning, and now I want to give you Turing's strange inversion of reasoning. This is Alan Turing, who, as much as anyone, deserves the title of the inventor of the computer. And I'm going to show you how close his idea is to Darwin's. Here's Darwin's strange inversion of reasoning. Remember, I quoted this before. In order to make a perfect and beautiful machine, it's not requisite to know how to make it. Here's Turing. In order to be a perfect and beautiful computing machine, it is not requisite to know what arithmetic is. In Turing's day, which is in our own lifetimes for some of us older folks, back in the 40s, 50s, a computer was a person. I'm a computer, a person would say. I work for some company computing. So computers were people. It was a job description, not a thing that you put on your desk or had in an air-conditioned room. And what Turing realized is that you could replace those human computers with machines, which we now call computers. And the beauty of it is that they don't have to know what they're doing in order to do perfect arithmetic. And if they could do perfect arithmetic and conditional branching, then they can compute any computable function. And thus was the idea of a universal Turing machine and of a universal information processing device created. So we have Darwin and Turing, who come up with different versions of the same idea, which is now, this is my bumper sticker. It's the theme I want everybody to take seriously and think about. Competence without comprehension. Before Turing, if you were doing computing, you had to know about mathematics. This was a fairly skilled job. You had to understand arithmetic and what it was, what it meant to compute. And he said, no, I can make a device that doesn't know it's computing, has no comprehension of what it's doing, but it's a better computer than you are, and it's competence without comprehension. Meanwhile, remember, that was Darwin's strange inversion of reasoning, that the process of natural selection, utterly lacking in comprehension, could nevertheless be competent to create the eye of the eagle, the wing of the seagull, the teeth of the tiger, and all the rest. Competence without comprehension. In other words, mind, consciousness, understanding is the effect, not the cause. Instead of saying that in the beginning there was a mind, the mind of an intelligent designer, and then that led to the creation of life, Darwin and Turing are turning that upside down and saying, no, in the beginning was mindless, mechanical stuff, just a lot of matter, and under the right conditions, what has evolved from that are things that are competent, without any comprehension, and gradually, over the billions of years of evolution, comprehension has emerged, mind has emerged by an evolutionary process. It's not the source of design, it is the most recent, one of the most recent effects of design. Termites are not intelligent designers. Beavers are not very intelligent designers. We are the first intelligent designers in the tree of life. And this has had a remarkable effect on life on this planet. An event that I call the Mccready Explosion. Now, this Paul Mccready, some of you may know of him as the great engineer, recently died. If you know the Gossamer Albatross, the human-powered bicycle plane that flew across the English Channel, that was one of his inventions. And he calculated that 10,000 years ago, which is just a blink of an eye in evolutionary time, 10,000 years ago, the human population, plus its livestock and pets, was less than 1%, approximately 0.1% of terrestrial vertebrate biomass. What does that mean? It means, forget the termites, they outweigh us by a large measure, just all by themselves. Forget the insects, forget the worms, forget the fish in the sea. Let's just look at animals. Terrestrial vertebrate biomass. 10,000 years ago, our ancestors, and this was Homo sapiens, this is long after the death of the other hominids that were around in those 6 million years. 10,000 years ago, the human population plus its domesticated plants and animals, domesticated animals, dogs and cattle and sheep, was 0.1% of the biomass, vanishing almost. What do you suppose it is today? Some of you may know because you've heard me talk about this before. Anybody want to hazard a guess of what the percentage by weight of human beings plus their domesticated animals is today? It's a lot more than 0.1%. What would you guess? 10%? 20%? 80%? Would anybody care to hazard a guess above 80%? Yes? No, not above 80%. Well, I'll tell you what it is. Today it's 98%. We have engulfed the planet. Most of that is cattle. This has happened in 10,000 years. That is one of the swiftest and most potent revolutions, one of the greatest explosions, the Mccready Explosion, in the history of life on the planet. And what made it possible? Technology, thinking, intelligent design, civilization, that's what made it possible. Mccready has a quite wonderful thing he says about it. Over billions of years on a unique sphere, chance has painted a thin covering of life, complex, improbable, wonderful, and fragile. suddenly we humans have grown in population, technology, and intelligence to a position of terrible power. We now wield the paintbrush. And how did we get this power? By another great technology transfer. It was the invasion of human brains by symbiotic thinking tools. In the same way that the invasion of prokaryotes into other prokaryotes created the eukaryotic cell, I am saying it was the invasion of our hominid brains with thinking tools that gave us this tremendous power. There's a term for such thinking tools made popular by Richard Dawkins, and that is memes. The term has taken off and has mutated into meaning something rather different than he meant. But if you want to know about the evolution of the meme, there's a whole section in my book about that. What are memes? They're ways of doing things that we don't inherit them from our genes. We have lots of things that we inherit genetically. We have instincts. We have lots of dispositions to do things, like things, shun things, perform various activities. Those are our instincts, and those are genetically transmitted. And what Dawkins says is, in addition to those, there are ways of doing things and of thinking of things that are not genetically transmitted. They're transmitted the way I'm transmitting to you right now, through perception. And we pass these around in the same way we pass around the virus that is making me cough every now and then. We pass them through the air. We pick them up. We are the hosts of not tens or hundreds or thousands, but hundreds of thousands of thinking tools, such as words, most of which have evolved without any human intervention at all. We are the beneficiaries of them without being their intelligent creators. We don't design them ourselves. Nobody has to design them. They're designed by differential replication of memes. It's exactly an evolutionary process. It is a bottom-up, mindless process where some ideas, some words, some ways of thinking or doing or styles or methods, they get passed on through the generations. They get passed to neighbors and associates, and some survive and some don't. And the ones that survive are the ones that are really good at surviving, whether they do us any good at all. So memes are made of information. Well, some people think, well, wait a minute, this is philosophy now, this isn't science. What do you mean memes are made of information? Well, genes are made of information too. It's the information in the DNA, not the matter in the DNA that does the work. Think of it this way. Poems are not made of ink, and genes are not made of DNA. DNA is the physical vehicle of the information of the genes, and the printed page or the CD-ROM or the inscription in marble is the information in a poem or in a scientific theory or in a history of Australia. The information is one thing, the physical vehicle is something else. Memes are made of information. They are habits or ways of doing things. Words are the best example of memes. Numbers are memes, poems, symphonies, theories. Proofs. One of my favorites, algorithms. What are they made of? Well, they're not made of carbon or DNA or nitrogen. They're informational things. They're just as real. for being informational things. They don't have to be made of any particular. They have to have a material embodiment of some kind, but it's completely neutral what that embodiment is. So now we're ready to explain, I think, the Mccready explosion. It was an explosive amplification of competence. It started as competence without comprehension, and it evolved into competence with comprehension. So we get the Darwinian strange inversion inverted. We start off with mindless, uncomprehending competence, which gradually evolves into the kind of competence that we call comprehension, and where the comprehension explains the competence, which is a very recent phenomenon on this planet. I have a term for this, which I maybe regret the term because a lot of people don't like it, but I'm stuck with it now. I've been using it for too long. And that's free-floating rationales. What are free-floating rationales? Well, you know, trees do things for reasons, but they don't know. They don't represent the reasons. They're designed by natural selection to do things, and there's reasons why they do the things they do, but they don't understand them. Those reasons are not represented in the tree. The structure of the tree not only permits but almost forces these things to be done, but there's reasons why they should be done, but the tree doesn't understand those reasons. Fungi do things for reasons. The biosphere, the biotic world, is saturated with reasons from the molecular scale on up. If you look inside a single cell and see a ribosome translating DNA into proteins, fantastic machine. And the parts, there's a reason why every part is the way it is. It has a job to do and it does it brilliantly. But nobody understood the reasons or represented the reasons until very recently, when some very clever human intelligent designers finally figured out by reverse engineering how the thing worked. That was the first time those reasons had ever been represented. Of course, we do things too for reasons that we don't need to understand. We shiver, we vomit, we blink for reasons. Let's take an obvious case which still puzzles us. Yawning. Nobody really knows why people yawn. It's not just people. Dogs and lions and other species also yawn. And it's a bit of a mystery. But people think there's got to be a reason. We just haven't figured it out yet. So reasons existed long before there was a representation of reasons, and all of life is saturated with them. But we also choose and decide and act for reasons that we don't need to appreciate. Many of the things we do in our lives turn out to be clever, and retrospectively we can notice this. But the idea that we knew what the reason was when we did them is often not the case. I'll give you an example if you're doubtful about this. How many of you have ever played a game of chess where you made a move which retrospectively turned out to be a wonderful killer move, but you hadn't realized how wonderful it was when you made it? Any of you? And did you admit that you didn't know? Or did you say, oh yeah, wasn't that, I had that one all figured out? No, that we do it all the time. And we rationalize our successes. And this creates the illusion that we're always articulating to ourselves somewhere in our psyches the reasons why we're doing what we're doing. Well, a lot of the time we aren't, even though what we're doing is very clever and very good. Other species do it all the time too. So now, what is the problem that culture solves? It solves the problem of how you get a Bach mind out of a termite colony brain. How do you get intelligent design with representation of reasons out of 86 billion mindless neurons? This was the second great endosymbiotic revolution, human culture. We're apes with infected brains. That's the key to our success. Let me go on for just a bit more. I'm going to give you a technical item that you don't have to understand the details of, but just to give you a picture to have in your mind. Peter Godfrey Smith, an Australian philosopher of biology and one of the very best in the world, in a recent book came up with what he calls Darwinian Spaces. And this is one of them. And the idea is that you can plot different features of evolutionary processes in these spaces, X, Y, Z, and you can see transitions over time from more Darwinian to less Darwinian. And I won't bother reading this diagram to you. This is one of his diagrams which shows how, let's see, we have up in the upper right-hand corner, the most Darwinian quarter, we have, say, a bacterium as a living thing which meets all of the conditions that he outlines below. And I'm going to simply pass over those. If you want to know about Darwinian spaces, it's a great new thinking tool in itself. You'll get a pretty good primer in my book of that. But I want to look at another Darwinian space, and this is the space in which human culture evolves. And what I want to suggest that when human culture got started 100,000 years ago, 200,000 years ago, a million years ago, it started off very Darwinian, clueless, termite-like culture. The first speakers didn't know they were speaking. They were getting benefits from these new ways of communicating without really realizing what they were doing. Gradually, this evolved into intended, pruned, edited, reasoned, evaluated speech of the sort that we're engaged in right now. And at that point, the search was very haphazard and undirected. People were just sort of bumbling around and discovering little oddities which improved their ways, their methods in various ways. But they were quite clueless about what they were doing. But this gradually, the products of all of this cultural evolution, which were mainly language and then eventually reading and writing and microscopes and telescopes and all the rest of that good stuff, so enriched the selective environment that you get, in the end, up in this corner here, you get intelligent design, where you have, it's high on comprehension, it's a very directed search, it's not just trial and error, but a very directed search, and it's very much top-down. That's where we put Gaudi. That's where we put intelligent designers. And I'm going to put Picasso up there. Now, why do I put Picasso there? Not because he's the most intelligent designer I can think of, but because he said he was. He once said, "Je ne cherche pas, je trouve." I don't search, I find. This is a brag. It is a cosmically outrageous and arrogant brag. Basically what he's saying is, I don't have to mess around doing grubby trial and error. I don't have to blurt it out and then fix it. I am so brilliant, I just go right to the highest point in design space every time. I hit a bullseye right off every time. I don't search, I find. Well, manifestly not true of Picasso, but it was cute of him to say it. By the way, part of Picasso's genius was he did a lot of searching. I've seen dozens and dozens of variations on a single drawing that he did over a course of a few days. His genius lay in selling all the bad ones too. That's something that evolution doesn't do. It lets them die. He figured he could sell the rejects as well. So that's an ideal of creative intelligence that even Picasso could not meet. But I want to put Bach up in that corner. That's why it's in the title. Why? Because Bach was an exemplary intelligent designer, had deep comprehension of what he was doing. He was highly constrained. His trial and error methods were beautifully directed by his own musical intelligence. It was constrained by knowledge, by foresight. Bach was magnificently equipped with thinking tools. One of them, of course, was the church organ. And by the way, which is itself a great thinking tool, great exploring machine. Bach, a lot of people don't know this, he was the Moog of his day. He was an expert repairer of organs. He knew how organs worked. He was an engineer of sort of musical instruments in his own time. He also, of course, knew music theory and had a vast knowledge of the history of music. So that's not a bare brain. That's a brain equipped with lots of fine thinking tools. Now, what's happened once we started getting thinking tools that we could then use to make more thinking tools, is that the pace of acceleration, the pace of R&D has accelerated thanks to this accumulation of thinking tools. And that thinking tools, that acceleration was itself created, I'm saying, by the natural selection of memes. Here's a rather vivid example. On the left, you see an Acheulean hand axe. On the right, a mouse. The Acheulean hand axe was made by our ancestors for 1 million years with no detectable change. Over 1 million years, they made the same hand axe. No sign of any real R&D there at all. They were very good at making them, but they didn't adjust them much at all. Now, nobody invented the Acheulean hand axe. Douglas Engelbart invented the mouse. Intelligent designer. But now look, the Acheulean hand axe was around for 1 million years. The mouse, which has only been around for a few decades, is on the verge of extinction. That's the difference in the pace at which cultural evolution now goes. Somewhat earlier, the philosopher Alain, writing about Normandy or Brittany fishing boats, had a wonderful thing to say. These were traditional Brittany fishing boats. Every boat is copied from another boat. Let's reason as follows in the manner of Darwin. It's clear that a very badly made boat will end up at the bottom after 1 or 2 voyages, and thus never be copied. One could say then with complete rigor that it is the sea herself who fashions the boats, choosing those which function and destroying the others. If it comes back, copy it. That's evolution. That's natural selection. That's pure Darwinian natural selection. You don't have to understand. You don't have to know why it's a good boat. You just do it that way because it works. And in fact, in the history of boat building, people tried all sorts of variations, improvements, and the ones that didn't work didn't come back. So gradually the boats got better and better, but not necessarily because the people were getting wiser and wiser about how the boats were made, but just because by this blind trial and error method, they were gradually improving the boats. But now, we've entered the age of intelligent design. To a fare thee well. Cultural evolution has become ever more top-down, ever more comprehending and self-comprehending, ever more refined in its search method. And so is genetic evolution, thanks to genetically modified foods and, say, Craig Venter. I won't go into all of that. Well, what next? The title of my book was From Bacteria to Bach and back. But that's perhaps enough for today. Thank you for your attention. Yeah. Thank you.
Thank you very much, Professor Dennett, for that fabulous talk. And now I open up to questions and answers.
Maybe you can go on with the back bit?
I'm
You said perhaps enough for today, but I would like to hear more about that.
still having trouble hearing.
She was really liking what you said, but could she hear more?
I didn't plant her in the audience. Well, I'll just give you a taste. What's happening now in science in particular, but across many different applications, is that Orgel's second rule is being appreciated. Crick's idea that evolution is cleverer than you are. And so we have all these new Darwinian or Darwin-esque methods, things like deep learning and genetic algorithms and Bayesian networks, which are artificial intelligence, the new wave of artificial intelligence tools, which are creating black box oracles that can get the answers better than we can get them with comprehension, and we don't understand how they get them. And they don't have to understand how they get them. And so we're already in a world where we're now relying on thinking tools that we ourselves, that not only are better at coming up with the answers than we are, and we can prove they're better than we are, but we don't understand them, and they don't understand themselves either. So the whole idea of comprehension is beginning to look a little shaky. Why bother with comprehension? You have scientists, important scientists, saying, why bother with comprehension? We got this gadget now in the lab that will figure things out and get us the right answer, and we can get on without ever comprehending the complexities of the things that it's analyzing. And that's one of the things that's coming. We're heading back in the direction of bottom-up, termite-like exploration of the world. Why? Because some of our intelligent designers have figured out that that's the intelligent way to do it. And that's a very unsettling prospect.
What do you think's going to happen to our termite brains now?
Well, as Yogi Berra, the great baseball sage, once said, prediction is very difficult, especially of the future. It's systematically impossible to predict the actual results of the evolutionary process for a very simple reason. I think this is an elegant, important idea. Natural selection, evolution by natural selection, works by amplifying noise. Every mutation is a little bit of noise that you couldn't predict. Noise is intervention which is not systematic, has no predictive, you can't predict it. And yet evolution proceeds by exploiting bits of, for all intents and purposes, random noise and then developing from there. And you never know what will be the outcome of the next little bit of random noise. We can't predict the future of evolution by natural selection directly, we can predict all sorts of things. What am I thinking? I'm missing a word that I want right here. Strange. I can't think of the word I want. We can predict, and science, of course, depends on prediction. We can predict what we will find if we look at fossils. Now, that's the kind of prediction that science requires. But we can't predict what will happen 1,000 years from now with anything like the rigor that we can use to predict what we'll find if we go searching in the past for various things. We can make conditional predictions in evolution, right and left. If this happens, then this is what will happen. If that happens, then we'll have something else happen. But we can't predict the future. We can look at trends and see that unless something intervenes, the following is likely to happen. And that's where I think human intervention becomes both important and difficult. I think that we can steer our own future cultural evolution if we identify the chief risks and opportunities, and then use what we have figured out already to plan and design ways of dealing with these. We can Ricky Skaggs once said, "I can't control the wind, but I can adjust my sail." And we can do that, and we should. We're getting dumber. Well, we're getting dumber about things that, in general, no longer matter. Let me. This will divide up the audience in an interesting way. First of all, how many of you can subtract 35 from 80? Yeah, in your head, no problem. How many of you, with a pencil and paper, can extract the square root of some number, like 21? There's an algorithm. Is there anybody? I learned this algorithm when I was a kid. I've forgotten it. It's pretty complicated. Is there anybody here who can actually execute by hand an algorithm for extracting square roots? Nah. Why? Because we got hand calculators. You just push the button and you get the answer. I don't think people wring their hands about that, nor do I think they should. We're all much worse at reading maps than we used to be. Cause for some anxiety sometimes. But in most regards, the only areas where we're getting, as you say, dumber is about work which was sort of drudgery in the first place and wasn't an altogether fitting use for our brains. We don't need the sort of mental persistence and agility to do, to multiply two 7-digit numbers together. If you can't, I'm sure you could do it if somebody paid you good money, but why bother? I think we have to look at it on a case-by-case basis. And one of the really serious ones is that when we now have expert systems, deep learning systems in medicine that can do a better diagnostic job than any specialist, then we begin to wonder if we really want to take steps to preserve the expertise of the specialist as it were, as a sort of safety net. And just, there's some real issues. I go into it in more detail in the book, but it's very open-ended on that topic. Okay, one more. Sorry, my answer
I'll try to make
too
this quick.
long.
Is this on? So you talked a lot about genetic evolution and how that's given way to social evolution. With the amplification or the speeding up of social evolution, is that threatening to replace genetic evolution, especially if we have things like genetic modification and CRISPR? And does it matter if it does?
You make a good point that, first of all, cultural evolution and genetic evolution have been co-evolving for thousands of years, for hundreds of thousands of years. Certainly, it's much easier for our children to learn to speak than it was for our distant ancestors when language was first around. Our brains have been selected for the capacity for language, for instance. And yet, as you say, we now have the tools, thanks to our intelligently designing scientists, so that we can start manipulating genes directly. CRISPR, gene drive, and the like. But it's interesting also that some of those techniques have the people working in those fields have discovered it's still better to do it in one sense the old-fashioned way, to use natural selection in the lab to breed better proteins rather than to try to construct them by hand, knowing why you're putting them together as they are. Sometimes it's easier and better and faster to just have a competition, a tournament with all these different novel proteins and keep selecting for the winners until eventually you get a protein that can do what you want it to do. That's exactly analogous to Darwin's remarkable discussion of selective breeding in the first part of his book, Origin of Species. We're now, as you suggest, able to tamper with and adjust and steer our genetic evolution. Does it matter? Still, it sure does, because in the process we may make some terrible mistakes that render us vulnerable. As you no doubt have heard, some people are declaring the end of the antibiotic age because our pathogens are evolving as fast as the new drugs we make that can deal with them. This is a very serious issue. So I think it's important to remember that natural selection, genetic natural selection, doesn't stop just because we can do it artificially. It still goes on. And we have to be careful that the products of our tampering with genes don't infiltrate into the wider world and create havoc. Some serious problems there.
First, do you think Darwin's remarkable idea is a metaphysical idea, or is it an idea within a metaphysics? And I wonder if you would say what that was. And secondly, do you see there's a range of do you think that there's a range of philosophical questions which don't get touched by Darwin, or does that cover everything, and affect everything?
As to whether Darwin's idea is metaphysical, I'm not sure what you mean by metaphysical. Is Einstein's thinking metaphysical? In some ways, yes, fantastically, wonderfully metaphysical. In other ways, no. For some people in philosophy, metaphysical is actually a term of abuse. For others, not. So the term is so loaded, I really don't know how to answer that. I would say that Darwin's idea is the best kind of metaphysics I know, because it's the one idea that unites the world of physics from the quantum level through chemistry to biochemistry, goes all the way from physics to poetry. It's the only idea that has any promise of uniting the whole of creation under a single perspective. I guess that makes it a metaphysical idea of the best sort. Now, your second question was, remind me? Oh, yes, right. Are there... Well, I'm not sure there's any that it doesn't touch, but there's a lot that it doesn't answer. Ethical questions about the meaning of life, have been often inspired by Darwin. A lot of people don't realize that Nietzsche was bowled over by Darwin's Origin of Species. It was a major impetus to his work. He didn't read Darwin directly, he read about it, but he got it. And it threw him into an amazing fury of activity, and essentially existentialism grew out of responses to Darwin. Pragmatism, Dewey's kind of pragmatism, grew out of Darwin. I think Darwin has had profound effects on the thinking of philosophers, not just philosophers of biology or philosophers of science, but on poets and artists and aestheticians alike. But it's very important that biology isn't just genes and it isn't just natural selection. There's ecology and physiology and all sorts of other specializations within biology. And in the same way, even if there is an aspect of culture that is illuminated by Darwinian thinking, which is what I'm claiming, there are all these other aspects which don't really get touched much at all by Darwinian thinking, and we should not try to see everything all the time through the lens of natural selection.
I'd like to draw the Q&A to a close. There's a couple of things. There were so many things that I took from this, but one of them was your evolving competence without comprehension into competence with comprehension, and your example was around speech. And I know what I'm going to keep thinking about, and that is how that may be similar to how we're now dealing with social media. In some ways, early on, it seemed like it was somewhat mindless, and now it's evolving into something else. And I thought it was a really nice example.
Thank you. I think there's much ore in that mountain to be mined.
Mm. On behalf of Charles Darwin University and the Darwin community, we're very grateful for your oration. It was absolutely tremendous. And I thank you all for attending. I have one small note before we retire for refreshments, and that is to remind you that the university is hosting another public lecture this coming Monday at Parliament House, the 8th Austin Ash Oration, titled Free Speech and the Law on Campus, Do We Need a Charter of Rights Just for Universities, by the Honourable Robert Shenton French, AC, And if you'd like to attend, please contact CDU Events. I'd like to invite you to stay for refreshments in the foyer, but I'm sure that you'd like to join me in thanking Professor Dennett one last time.
Thank you very much. Thank you.